Ever wake up to a winter morning so cold it hurts to breathe? The kind of cold that makes your breath hang in the air and your eyelashes freeze. It's a chill that seems to seep right into your bones, making even the shortest walk outside feel like an adventure. Sometimes, that deep freeze is more than just a regular cold snap. It's something much bigger, the polar vortex. You might have seen it in the news, blamed for record-breaking cold spells and wild winter weather. This isn't science fiction or a plot from a disaster movie. The polar vortex is a real, powerful force of nature that can make parts of the US feel like the Arctic almost overnight, catching millions off guard. So, what exactly is it? The polar vortex is a massive area of low pressure and frigid air swirling high above the North and South poles, acting like a giant cold air reservoir. Most of the time, a strong jet stream acts like a barrier, keeping this icy air locked up tight in the Arctic, far from our cities and towns. But when that jet stream weakens or becomes unstable, the vortex can wobble, stretch, or even split apart, sending blasts of polar air surging southward into North America and beyond. That's when cities like Chicago or New York suddenly face record-breaking cold, with streets turning into icy wind tunnels and daily life grinding to a halt. Temperatures can plummet by 20 or 30 degrees in a single day. A true polar vortex event that leaves people scrambling for extra layers and emergency supplies. It's a dramatic reminder of how powerful events above the North Pole can reach down and impact our daily lives, no matter how far away we are. In this video, we'll break down what the polar vortex is, how it forms, and why it sometimes escapes its polar home to bring winter's fury to our doorsteps. We'll look at recent deep freezes, explore how they affect everything from travel to energy use, and discuss what climate change could mean for the future of the vortex in our winters. Ready to find out why science is cool and sometimes very, very cold? Bundle up and let's dive in. The polar vortex isn't new. This swirling phenomenon has been a part of our planet's climate system for as long as we've been studying the weather. In fact, meteorologists have tracked and analyzed it for decades, using advanced technology and satellite data to understand its behavior. There's actually a polar vortex at each pole, both north and south, spinning high in the stratosphere. These vortexes are strongest during the winter months, when temperatures drop dramatically. Why does this happen? It's because the pole tilts away from the sun during winter, losing precious warmth and allowing dense, cold air to build up over the region. This sharp temperature difference between the icy pole and the milder, mid-latitudes creates a powerful pressure gradient. It's like a figure skater pulling in their arms to spin faster. The vortex tightens and spins more rapidly. The jet stream, a fast-moving ribbon of air, acts as a kind of invisible fence, keeping the coldest air locked up near the pole and separating it from warmer regions. When the jet stream is strong and stable, the polar vortex stays tight and contained over the Arctic, swirling in a nearly perfect circle. But if the jet stream weakens or becomes wavy, it can allow frigid Arctic air to spill southward, reaching places that aren't used to such cold. The polar vortex isn't a storm you see outside your window. It's a vast, swirling mass of cold air high above us, shaping our weather from the stratosphere. What we feel on the ground, those sudden blasts of icy wind and snow, are the result of the vortex being disturbed and letting cold air escape. In a way, the polar vortex acts as the Arctic's gatekeeper, and when it slips or weakens, we get a taste of the deep freeze it usually keeps locked away. Understanding how the polar vortex works is key to knowing why our winters can suddenly turn so extreme, bringing record-breaking cold and snow. The polar vortex is always present, swirling above us, even if we don't always notice it. Sometimes, though, it just pays us a dramatic visit. So, let's take a closer look at how this powerful force of nature really works. The polar vortex is like a giant spinning top of cold air, and it actually has two main parts. One in the troposphere, which is the layer of the atmosphere where all our weather takes place, and another, even larger part, swirling high above in the stratosphere. The stratospheric vortex forms as the North Pole enters its long, sunless winter, creating a dramatic and sharp temperature contrast with the much warmer south. This contrast acts like a powerful engine, fueling strong westerly winds, known as the jet stream, that circle the pole and trap the cold air inside the Arctic. The colder the pole becomes, the faster and tighter the vortex spins, keeping the frigid Arctic air locked in place. But the atmosphere is always in motion, always changing. Large weather systems from lower latitudes can send waves of energy, called planetary or Rossby waves, upward into the stratosphere, nudging and sometimes distorting the vortex. If these waves are strong enough, they can disrupt the vortex, stretching it out of shape or even splitting it into two separate swirling centers. This dramatic event is called sudden stratospheric warming, when the air in the stratosphere warms rapidly, though it's still bitterly cold, weakening the vortex's grip. Like a figure skater opening their arms to slow down, the vortex loses speed and stability, wobbling and letting cold Arctic air spill southward. When this happens, the Arctic's deep freeze is no longer locked away at the top of the world. It escapes and surges into lower latitudes. The result? A dramatic and often sudden shift in winter weather for millions of people, bringing intense cold, snow, and wind. The polar vortex is stable until it's not. Its breakdown can be swift and surprising, and when it breaks, we feel its icy reach, sometimes for weeks at a time. Let's follow what happens next, and see how this spinning top of cold air can change our winter in an instant. When the polar vortex weakens, it can stretch or split, sending lobes of cold air south. The jet stream, now wavy and weak, develops deep troughs that let Arctic air plunge into the US. This isn't a global cold snap, it's a redistribution of cold air. While the Midwest freezes, places like Alaska might get a warm spell. The displaced vortex can linger for days or weeks, bringing prolonged, dangerous cold. It's not just a passing front, it's a stubborn mass of Arctic air. The result? Record low temperatures, high heating bills, and constant warnings to stay safe. The journey south is swift and dramatic. The cold settles in, disrupting daily life. This is the polar vortex's calling card, a relentless, icy grip. When the Arctic visits, it doesn't leave quickly, and the impact is felt everywhere. Recent history gives us dramatic examples of the polar vortex in action. In January 2019, a disrupted vortex sent Arctic air deep into the Midwest. Cities like Chicago and Minneapolis saw temperatures colder than Antarctica. Wind chills dropped to -60 degrees in Minnesota. Chicago set its train tracks on fire to keep them from breaking. The U.S. Postal Service suspended mail delivery, and daily life ground to a halt. In February 2021, another vortex disruption sent frigid air all the way to Texas. The state's power grid failed, leaving millions without heat in freezing conditions. These events show how a wobbly vortex can paralyze even the most prepared cities, and devastate those that aren't. The consequences are more than just cold, they're life-changing. What happens over the North Pole can have life or death impacts far to the south. The polar vortex is a force to be reckoned with. To understand the polar vortex, let's clarify a few key terms. The stratosphere, the atmospheric layer 6 to 31 miles above us where the polar vortex forms. The jet stream, a fast, narrow river of air in the troposphere, acting as the boundary between cold and warm air. When the vortex is strong, the jet stream is straight. When weak, it becomes wavy, letting Arctic air escape. Sudden stratospheric warming, SSW, a rapid warming event in the stratosphere that disrupts the vortex, triggered by planetary waves. This weakens the vortex, allowing cold air to spill south. Wind chill, what the temperature feels like on your skin when wind strips away your body's heat. During a polar vortex event, low temperatures and strong winds combine for dangerously low wind chills. Frostbite can occur in minutes. These terms help explain why a polar vortex event is so extreme. It's not just cold, it's a complex chain reaction in the atmosphere. Knowing the science helps us prepare. Let's see how these events affect our world. When the polar vortex arrives, its impact is immediate and widespread. Infrastructure takes a hit, pipes burst, power grids strain, and blackouts can follow. Travel grinds to a halt, icy roads, canceled flights, and public transit shutdowns isolate cities. Health risks soar. Frostbite and hypothermia threaten anyone exposed, especially the vulnerable. Cities scramble to open warming centers for those in need. Daily routines are upended, schools close, errands become expeditions, and even furnaces struggle. The cold tests every part of our interconnected systems. A polar vortex event is a stress test for society. It reveals how fragile our infrastructure can be in the face of nature's extremes. The lesson? Preparation and resilience are key. The polar vortex is more than a weather event, it's a societal challenge. If the planet is warming, Why do we get these extreme cold snaps? The answer may lie in Arctic amplification. The Arctic is warming twice as fast as the rest of the planet. Melting ice exposes darker surfaces, absorbing more heat and accelerating warming. As the Arctic warms, the temperature difference with the mid-latitudes shrinks, weakening the jet stream. A weaker, wavier jet stream lets cold air escape south more easily. Some scientists see a link between Arctic warming and more frequent vortex disruptions, though the debate continues. The atmosphere is complex, and separating climate change signals from natural variability is tough. Still, the evidence is growing. Climate change isn't just about hotter summers. It's about more unpredictable extremes. The polar vortex is a vivid example of how a warming world can bring surprising cold. Understanding this link is crucial for our future. The polar vortex is a natural part of our climate system, but when it weakens, it can unleash severe winter weather. Understanding the science helps us prepare and stay safe. These cold snaps affect everything: infrastructure, health, and daily life. Preparation is key. Emergency kits, layered clothing, and checking on neighbors can save lives. On a larger scale, we need resilient infrastructure to withstand these extremes. The link between a warming Arctic and a wobbly vortex is still being studied. But the risks are real. Climate change means more than just heat. It means bigger swings between extremes. Listening to science and planning ahead can help us weather the storm. The polar vortex will keep returning. With knowledge and preparation, we can stay safe, even when the Arctic comes to visit.